Good. We're now recording.
Hello?
Hello? Yep.
Hi, yeah, so I do have a question. I'm just trying to get all my docs ready for what we're going to go over.
Okay.
Are we going to be going into that Excel sheet you have uploaded in week 3?
Yes, we are.
Okay.
Hi，我待会儿跟你们做，我先上楼。
Okay.
Okay, we'll give you like 1 more minute. Let's start at 6:05. Okay, I'm going to switch to the share screen. Okay, so here we are in the Blackboard page. And so just let me pull up the chat feature so you guys can. Okay, so kind of like last time, if you have any questions, you can post them to the chat feature. Or if you have a bigger question, you can just you can ask it just like you asked it. And if you're not, but if you want to go ahead and everybody can turn their sound off, and so that way you guys can just hear me for now, unless you have a question. So try to mute your feed, and that way we don't have any background noise. So it looks like most people are muted, but there might be 1 or 2 that are not. Okay. So any questions or comments, you can ask them by turning your sound on, or you can post them to the chat. So there's that. Okay, so it looks like most people are logged in, so there might be a few more late joiners, but we can go ahead and get started. Okay, so this is where we are. Okay, so week 1, last week via WebEx, we did chapters 1 and chapter 2. Nothing was due last week, obviously, because that was our first week. And today, you just have your homework for chapters 1 and 2 due. And it looks like, it looks like everyone's turned it in, so you guys are on top of it. So thanks for being so prompt with your assignments. And yeah, so I'll explain where we're going from here, but it looks like everybody figured out where to put their homework, and we've got everybody's homework turned in for homework chapters 1 through 2. So I'll look at those when I have some time, and I'll post the solutions. So it looks like you guys did pretty well on that. Okay, and then today what we're going to do via WebEx, via our meeting, is we're going to do chapter 3 in your textbook, and then next week. So I have a few things that I'm going to present today for homework assignments. The first is a pretty short homework that's for chapter 3, which is going to be the next week. And so if you look on the discussion board under forums where you guys went to last week, you'll see there's a thread for homework chapter 3. All right, so there's where that goes. And then I also have a longer homework. It's called the elasticity homework, which we're going to cover in chapter 3. This used to be a group project, but we're not going to do any group projects because you guys cannot meet with each other. And so I just kind of modified it a little bit, and it's going to be just a longer homework assignment. This will not be due until it's on the syllabus. Let me see. Week 6. So this, I'll go over it today, but it's a little bit longer. You got to use Excel if you have access to it. Hopefully everybody's able to do it, but you got some time. And so we're going to present two things today, homework-wise. The first is homework chapter 3, which is due next week. It's a lot shorter. I think it's only one question. And the elasticity homework, which is more of a longer project, but that's not due until week 6. Okay, so there's two things I'm going to show you guys that you have to do. But homework 3, chapter 3 is due next week. The elasticity homework, which is a whole separate thing, is not due until week 6, May 3rd. May 1st. Okay? So, let's start with, unless we have any questions, let's start with doing chapter 3, covering that first. And then I'll show you guys the homework for chapter 3. And then I'll show you guys the elasticity homework. And again, that's not due until May 1st. Actually, the same day as the midterm. Okay, so you got plenty of time to do it. It shouldn't take you too long, but it's a little bit longer than a normal homework assignment. So try to do it when you have time, because you also have the midterm due May 1st. So I'm sure you can do both of those in a week if you want to, but if you want to cut down some time, you have this one already done, or you will. All right, so let's look at the documents for chapter 3. Okay, so I'll have this open as well. This is what I showed you last time with an older PDF of the textbook. We can look at that from time to time. And you want to open up the PowerPoint for today is chapter 3. Okay, and then I'll mention some optional videos if you guys want to look at those later. And and then here, so here is going to be the end of the chapter 3 on the blackboard. We'll get to this a little bit. You have homework for chapter 3. You have the elasticity homework, and this is some data you'll need for the elasticity part, and then this is for that as well. So we'll get to those in a minute, but again, elasticity homework is not due for a few weeks. All right, so let's start with going through chapter 3, which is going to be looking at elasticity, and we're going to do some statistical analysis in Excel. And if you don't have, you're not able to use Excel right now, and we do some stuff together, that's okay. You can do it in your own time, and if anybody does not have Excel at all, you can let me know, and we'll try to work something out. But I think at least at least you should have access to the Excel online version. And I think that has a lot of the features you might need the regular Excel, but let's see what we can do. And if you guys don't have the real, don't have the full version of Excel, and you can't do some of the analysis, I can try to do it for you, but just let me know afterwards if you don't have access to Excel. All right, let's start with chapter 3. Okay, this is on quantitative demand analysis, which is mostly looking at demand curves and in particular elasticity and how we can look at that with actual data and make some predictions. Okay, so some of this might be reviewed from Biz 500B, but we didn't do like actual data analysis back then, which is what we're going to do today and going forward. All right, there's an optional video. You might have watched this in Biz 500B, but it's a little intro to elasticity if you're interested in watching that. That's on there. Okay, so here's what elasticity is. Again, this might be reviewed, but you're going to look at this again. So it's just elasticity in general is looking at the responsiveness of one variable to changes in another. And another way of saying that is the percent change in one variable that arises or happens after there's a certain percent change in another. So you're looking at how one variable responds to another variable, and the first thing we're going to look at is how demand responds to price, percent-wise. Okay. So the own price elasticity of demand is the first elasticity we'll look at, and this is probably there's some other names for this. The price elasticity of demand, the own price elasticity, and so this is when you look at like the elasticity of a demand curve. There's a couple different names, but it's the same thing as when we talked about the price elasticity of demand in Biz 500B and just in general. Okay, so what it is? All right. So it's a measure of the responsiveness of the quantity demanded of a good to a change in the price of that good. And another way of saying that is the percent change in quantity demanded divided by the percent change in price. So we're looking at how responsive demand is to the price in percent changes. So we know the law of demand states that when price goes up, demand goes down, and vice versa. But we're looking at how responsive demand is, because there's a huge difference depending on demand and firm decisions. All right, let me just jump to this real quick. Okay, so the notation might be a little different than your other textbooks, but it's the same concept, the exact same concept. And so the notation in this textbook, if you can see this, let me make it a little bigger there. All right, so we have E is elasticity, and this is the variable that's affecting this variable. So Qx is the quantity demanded of X, and Px is the price of X. And so the elasticity in math terms is just the percent change in quantity demanded divided by the percent change in price. All right, so this little equation shows you that. And this is somewhat familiar from Biz 500B or any introductory economics, but we're going to look at this in more detail. Okay, so hopefully you have some recollection of what the price elasticity of demand is, and we're going to be working with that for a little bit. Okay, let's talk about the ranges of elasticity. All right, and so you know that if something is more responsive to price, if it responds more than the price change and percent-wise, then it's more elastic or more responsive, and so just the cutoff is 1. And so if the absolute value of the price elasticity of demand or the own price elasticity of the same thing is bigger than 1 in absolute value, then that means that that's an elastic good. It responds more percent-wise than the price change. All right, and if the in absolute value of the own price elasticity is less than 1, that means demand is less responsive than the price change percent-wise, and we call that inelastic. Okay, and there's another case where if it's an absolute change, if the percent change in price is exactly the same as the percent change of demand, if that's the case, which is unlikely, we have a unitary elastic demand. Yes? Okay, so let's look at how this relates to total revenue, and we can see that in Figure 3.1 in your online textbook. Okay, so here on page 76, you'll see the little, if you need a refresher on the definitions of what's inelastic or elastic. If that elasticity again is bigger than 1, it's elastic. If it's less than 1, it's inelastic. And if it's just exactly equal to 1, it's unitary elastic or unit elastic. All right, this is a nice little figure, and I think we briefly talked about this in BS 500B. Actually, we might have done a homework assignment or 2 on this, but let me review because this is important. And so here we go. We have a linear demand curve, just for simplicity. And this is price, and this is quantity. Okay? And so you know that you have a downward sloping demand curve because when price goes up, demand goes down, etc., the law of demand. And you see that even though you have, in this case, a constant slope, so it's linear, you do not always have and you usually don't have a constant elasticity. The elasticity changes in different regions of the demand curve, and you always have an upper region, which is more elastic, and you always have a lower region, which is more inelastic. Now, the total distance of these regions change if the curve gets steeper or flatter, but you always have some portion of the demand curve that is elastic and some portion that's inelastic. Okay, and depending on where you are in your demand curve, where the market price is, that dictates or gives you like a recipe for what you should do as a manager to your price. Okay, and so basically, this relates to total revenue for the firm. And so what you can see is that if you're in the upper, or if you're in the elastic region, if the price change is in the elastic region, then the way to increase revenue is to lower your price. Okay? But if you're in the inelastic region, the way to increase revenue is to increase the price. Okay, so if you're a firm operating in this region, the roadmap to increase revenue is lower your price, and that's because it's elastic, so there's more substitutes, and therefore you're trying to get more customers by taking them from the other substitute by lowering your price, and that will give you more revenue in theory. And if you're in the inelastic region, that means there aren't a lot of substitutes, and so if you increase your price, the extra revenue you get from the consumers paying a higher price is better than the customers you lose. And so basically here, the customers are less responsive, so you want to increase your price. And here, the customers or demanders are more responsive, so you want to drop your price. And you can see that on the little total revenue curve here, a map. And so here's total revenue for some hypothetical firm. All right, and you can see that this relates to this exactly. And so if the price is in the elastic region, they want to increase the price to get more revenue. So once it turns into the inelastic region, then you want to here you want to decrease price, and here you want to increase price. So you want to be aware of what kind of good you have and what kind of market you're in as a firm. And if you can calculate that you're in the elastic region, then you probably have a lot of substitutes for your good or service, and you might get more customers by cutting your price. Now you don't want to go too far, but if you're in this region, you can cut price. And if you're in the inelastic region, you can raise price, get more revenue by getting the consumers pay more, because you probably have less substitutes for your good or service. All right. So do you see kind of the relationship here between elasticity and revenue for a firm? Okay. All right. Well, let me know if you have any questions thus far. Then the next thing. Okay. And so we defined elastic demand. We defined inelastic demand, and we looked at the total revenue test, if you will, what the firm should do in different elasticity regions of the demand curve. There are two extremes that you might be familiar with, and so if your elasticity is perfectly elastic, that means the own price elasticity is infinite or equal to infinity. And we'll look at a graph of this. And if demand is perfectly inelastic, that means the own price elasticity is zero and there's no response. So these are the two extremes, and I think those are in figure 3.2. And so here's price and demand, price and quantity and price and quantity, and this is what the demand curve would look like for a elastic or perfectly elastic fit. So it's a horizontal line, which essentially means that this good or service or market represents perfect substitutes. And so therefore the market demand has determined what the price is for this good over the long run. And this is the price those consumers will pay, and therefore the firm can either supply or not. But the firm cannot raise the price in this scenario because doing so would lose all the customers because they're only willing to pay this price. And so that's the price for this perfectly elastic good, which again would represent perfect substitute. So the other extreme is perfectly inelastic, and it looks like this. It's a straight vertical line showing that the consumers or demanders don't respond to price changes at all. All right, so no matter what the price is, the demand is going to be the same for that good or service. Okay, and these are extremes, so they're a little unlikely, but an example of a perfectly elastic good would be, again, something with perfect substitutes, or like a lot of agricultural goods or farmers market things that are the same exact good. And an example of a perfectly inelastic good where the consumers buy it no matter what the price is probably something that's very vital, like some kind of surgery or insulin, in this case, a vaccine for this virus would be something like that. Stamps? For which one? So stamps would definitely be inelastic. I don't think it'd be perfectly inelastic. because I don't think people would pay like $100 for a stamp if the price went up some crazy amount, but they're probably pretty inelastic, so they'd be more of a steep downward sloping demand curve. So probably, you know, in the inelastic region, but not perfectly inelastic. Yep. Yes, the stamps would be inelastic. Okay, so like you said, but definitely not perfectly inelastic. Okay, you're welcome. All right, so next slide is, let's look at how marginal revenue relates to elasticity. Figure 3.3. All right, so here's demand and elasticity and marginal revenue. And we'll talk about this more when we look at, revisit the different types of markets, like monopoly and pure competition and oligopoly in the latter chapters. But you can see that there's a relationship between the marginal revenue and the elasticity. Okay? So when you're in the elastic region, what you want to do is keep lowering your price because your marginal revenue is increasing. And so in this whole region, you're getting more additional revenue on the margin. So each price change gives you positive revenue. But once you pass this point, and you're getting each additional drop in price, you're losing revenue. All right. So if you're again in this region as a firm, you want to cut your price, and if you're in this region as a firm, you want to increase your price. And you can see the marginal revenue corresponds to those marginal changes in price. All right, so we have a few more types of elasticity we'll briefly define. We'll spend most of our homework and analyses on the demand elasticity, the own price elasticity, but actually we'll look at some other ones as well. So we're going to look at the income elasticity, and so this one, the cross price, the income, and then I think advertising as well plays a role. All right, so the cross price elasticity measures the responsiveness of the demand for a good to the change or changes in the price of a related good. Okay? So it's the percent change in quantity demanded of one good divided by the percent change in the price of some related good. Okay, so this we looked at when we looked at substitutes and complements, and so this would show us the responsiveness of your competitor or your substitute good. Okay? We also have an income elasticity, and this measures the responsiveness of quantity demanded to changes in income. So it's just the percent change in quantity demanded divided by the percent change in income. All right, and this would show, first of all, a normal versus inferior good that we talked about last time, and also how responsive those goods are to the income changes in percent terms. Okay, so it's the exact same concept. We're basically looking at a bunch of different things that affect demand, and now we're trying to measure or figure out how responsive they are. Okay? So here's the cross price elasticity. This is the elasticity of, here's the quantity of good X, and here's the price of good Y, of some related goods. Okay, and so the elasticity is the percent change in quantity demanded of X divided by the percent change in the price of good Y. So this would be looking at like, if you're looking at substitutes, you can be looking at like Coke and Pepsi, or if you're looking at complements, you could be looking at like milk and cereal or something like that. Okay, so in addition to substitutes versus complements, this would show you exactly how responsive your good is to the price of some of the good. All right, and then this is the notation for the income elasticity. The big M is for income, so this is the elasticity for here's the quantity of good X, and M is income. And it's the same idea. So it's the percent change in quantity demanded of X, good X, divided by the percent change in income. All right, so how responsive is your demand to income changes? All right, so if income goes up by a certain amount, how much more, how much less do the consumers change their demand percent-wise? All right, and then we also have an advertising elasticity, which I don't think is defined in the chapter, but we'll look at it. It's the same exact concept. I think there's one or two homework problems on it, or in the longer assignment, but it's just looking at how demand responds to advertising expenditure changes. All right, so everybody good so far? If you have any questions or comments, please you can post them in the chat or you can ask them out loud. All right, so we're going to look at some linear demand curves or demand functions that we talked about introduced in chapter 2. So we introduced a demand function and a linear demand function. Now we're looking at these elasticities, and we can define them based on the specific linear demand function. And we know that demand is elastic at higher prices and inelastic at lower prices, just like we saw in that total revenue test picture. Okay, so this is important here because we're going to, well, it's building up to what we're going to analyze in Excel later. So if this is a demand function, let's say this represents the notation for here's the quantity demanded of X, and that's equal to some intercept, and then again the effect of the price of that good on demand, the effect of the price of some related goods on demand, and also the effect of income on demand, and then the effect of all the other things. Okay, so based on this coefficient, if you will, this is like the slope or the linear effect of the different variables on demand. We can define the elasticities with the slope coefficient. Okay, so the own price elasticity based on this linear specification is just equal to this coefficient, which is equal to the slope, the alpha x, times the price of good x divided by the quantity of good x. So it depends which price and quantity you're at, but this slope always helps you determine the own price elasticity identity. Okay, so this is how you calculate it, but it depends where you are. So when you plug in different prices and quantities of a demand curve, this calculation will change. You always use this terminology together. Okay, and you can calculate the cross price elasticity the same way. It's just the slope of this relationship between the price of good Y and the demand for good X, alpha Y, times the price of good Y divided by the quantity of good X. So again, these numbers depend on where you are on the curve, but you always calculate it like this, and then you can do the same for income. Okay, so the income elasticity, you can use the slope or the coefficient of the linear relationship between income and demand. And the way you calculate it is just that slope coefficient, alpha subscript m, times m over qx. So basically, if you get the elasticity, you plug in where you are with these variables and then just multiply it by the linear slope for each respective elasticity. Okay? Alright, so now we're going to introduce a log linear demand function, and the reason why we're going to do this is because it's a lot easier if you have actual data, and I'll give you guys some data to work with the homework for the elasticity. If you have actual data, and you can assume that it follows a log linear demand function, which it often does. It doesn't always, but if you can assume this relationship, and I'll show you what this relationship means. If you can assume this relationship, then it's a lot easier to calculate your elasticity based on data analysis. Okay, so just demand is log linear. If the log of demand is a linear function of the logs of price, income, and all the other variables that affect demand. Okay, and the way you would term that, or the notation, okay, is just like this. And so we usually use the ln, the natural log, and so it's a specific type of logs that we often use in economics. And so ln is the natural log. Okay, and so you're defining this big relationship that we looked at before, and the only difference is things are now expressed in natural log form. Okay, so the natural log of supply and demand of good x is a linear function of an intercept, the natural log of the price of good x, the natural log of the price of good y, the natural log of income, and then the natural log of h, which is everything else. Okay, and so if we can define our demand curve like this, then I'm going to show you it's a lot easier to estimate statistically the elasticity. Alright, so let's look at the elasticity calculations or notation for a log linear demand curve that we just defined. And so you can get from that specification the own price, the cross price, and the income elasticity. And the neat trick here is if you can make this determination is that when demand is log linear, the elasticity with respect to a given variable is just the coefficient of the corresponding log. Okay, and so let me show you what that implies. Alright, so here's our log linear demand specification that we just looked at. And the way you would determine or calculate the elasticity if it follows this relationship is just the elasticities in this form are just the coefficients. So basically, the own price elasticity is just the coefficient for ln px, so just that beta x. The cross price elasticity is just the coefficient for ln py, or beta y. And the income elasticity is just the coefficient for income, ln income, which is beta n. Alright, so all of these, so basically what I'm saying is the linear effect of ln px on ln q dx is just dx. And that's also the elasticity. And so what we're saying is that if your demand follows this specification, the elasticity is always the same. And this is a really nice feature because if you can transform your data into this form, into natural logs, you can estimate the elasticities by simple statistical analysis by just estimating the coefficients. And the reason why it's like this is, let me give a little picture. I'll go back up in a minute, but let me just show you, there's a graph I want to, here you go. Okay. So here's price and here's quantity. So our demand curve is a downward sloping curve. And so a natural log relationship has kind of a bended relationship like this. And so you know your demand curve is not going to be exactly like that, but if it's close to it, you know, this one kind of passes through the points. If you can make an argument for this being a good graph or relationship for your demand curve, then if you assume this natural log form, which is this red line, then what it kind of simplifies to is the elasticity based on the calculation is always the same. So because of the curve and the way the natural log properties hold, each change is going to give you that same elasticity. Now, we're simplifying, but it's a pretty good feature of using this natural log relationship, because if you do that calculation, each change, like if you go from here to here or here to here on this red curve, it's always going to give you the same elasticity based on the natural log properties. Okay, so if you can make an argument for your demand curve following this natural log form, it's a lot easier to get elasticity and recalculating in every single point. Okay, so that's what we're going to do in a little bit, but any questions on how this, what we're doing here and how this relates to elasticity? We're making a simplification of a nonlinear relationship because it's a lot easier to translate if your equation follows, if your relationship between price and demand follow this pattern. And if you can do that, you can really calculate your elasticity is a lot easier based on real data. Okay, so here's where we left off. And so if all of our variables follow that kind of curve log linear relationship, then we can assume that the coefficients or the slope of that the slope of the natural log of price versus the natural log of demand is just equivalent to the elasticity based on the properties of the natural log function. All right. So any questions thus far? Everybody doing all right? Okay. Well, nobody left yet, so I think we're doing all right. All right. So let's move on to the next slide. Okay. So we're going to briefly, at the end of this chapter, we're going to introduce simple regression analysis, and we're not going to go too deep into statistics and regression, but we got to do some of it because this is how we're going to estimate elasticities from some actual data points. All right, and so you're probably familiar with this concept if you've taken any statistics or econometrics kind of course. If not, I'll kind of refresh your memory, and we're not going to do too much on this, but what we're doing here is we're just trying to estimate a linear relationship between one or more variables, okay, based on real data. All right, and so this is the simple one variable case where we have y is a function of some variable x, and y equals a plus bx plus e. And so what this says, statistics-wise or econometric-wise or the simple regression analysis equation is that little b, is the linear effect of x on y, a is the slope, and then e is the error, or whatever we didn't capture with the specified equation. Okay, so let me show you figure 3.4. Alright, so there's that equation repeated, and what you're probably familiar with this concept, but just to refresh your memory, here's a nice little graph, and so if we have all these points, A, B, C, D, E, and F, so 6 points that plot different combinations of x and y, and we're trying to estimate the relationship, the linear relationship between x and y. In particular, how does x affect y? Then what you do, based on the linear regression, is you get a program. We're going to use Excel to estimate a line that gives you the best linear relationship between those points. And to do that, we're just kind of minimizing the distance. So this line will give you the best line, or best straight line, that minimizes the deviations between all the points. And so we're trying to estimate a linear curve, or a linear relationship between x and y, based on the actual data points. Now, it's not going to be a perfect relationship because you can see the points are not right on the line, but if it's close enough, we can make lots of inferences based on it. Okay, so you might be familiar with this common practice in regression. It's called least squares, and that is, we're going to estimate a line that minimizes the sum of the squared deviations between the line and the actual data. Okay, if you look at this simple example, here's all the different points, or the 6 points. Typically we have more points, but this makes it simple. And so this is the best line when it takes these deviations. So like this distance, this one's right on the line, so that's good. This distance, and it minimizes the sum of the squares. So like this distance squared plus this distance squared plus this distance squared plus this distance squared. Okay, so this line gives you the best possibility of minimizing those deviations, and you square them because it takes away the negative effect. Okay, so what this is saying, there's no better line that would minimize those squared deviations. No nonlinear line. All right, and so we have a couple, 2 or 3. We're not going to look at too many of when we do the regression with Excel. When I do it, and you kind of see what's going on. You get a lot of output, or like things that go along with the estimation. And so we're not going to look at everything, but I'll point out a few important things that we can look at to kind of evaluate how good the estimation was. All right, so the first is the t-statistic. Okay. And so this is the ratio of the value of a parameter estimate to the standard deviation of the parameter estimate. Okay, so it's just it's a simple ratio, and okay, so it just calculates it like this. This A is the estimated coefficient, so this is like the estimate for that B. Okay, so we're trying to estimate this effect of x on y in a linear fashion, so that B is going to be a coefficient. Okay, and so the t-stat just takes that coefficient that Excel or whatever software will estimate and divides it by the standard error. And so basically, the smaller the standard error, the higher the t-stat. Okay, so the lower you can get your error, like how far off it was from the actual data, then the better this t-stat is. And we'll have kind of a rule of thumb, and we'll use this for the elasticity homework, and that rule of thumb is right here. Oh yeah. Okay, and so the rule of thumb is that when the absolute value of a t-stat is bigger than 2, then the manager can assume or be 95% confident that the true value of the underlying parameter in the regression is not 0. Okay, so that's the rule of thumb we're going to use in the homework and the problems we look at, is that if our t-stat from the regression for each coefficient is bigger than 2, we can assume, we're 95% sure that we can talk about our results and our interpretation. If it's less than 2, which it will be sometimes, then you have to assume that it's not a good fit and your kind of statistical relationship does not hold. Alright, so it's pretty easy to memorize, but this is the rule of thumb that you're going to compare to is basically, is that number bigger than 2? And if it is, you're 95% sure that it's, there is a relationship. Okay, there's an earthquake? Well, I must have, oh, where are you guys? Oh wow, okay. So I didn't feel the earthquake in Claremont. Oh, you did? Okay, well, I must be, maybe it's, more near Los Angeles. Alright, well, hopefully everyone's alright and it wasn't crazy, was it? Okay. Well, I don't think we lost anyone at the earthquake. Everyone's still here. Alright. Okay. Well, yeah, I didn't feel it. I hardly ever feel, I drink too much coffee. I don't feel the earthquake. Okay. Oh yeah, definitely didn't reach Santa Barbara. Alright, so another way we can evaluate instead of the regression is to look at this thing called the coefficient of determination, or the R-square. And this is a simple calculation that Excel or whatever software does for you. You don't have to do it. But it's the fraction of the total variation in the dependent variable, so y, that's explained by the regression. So it's calculated by the explained variation divided by total variation. And we also have a different, better metric called the adjusted R-square. So let's look at these real quick. Okay, so the R-square is calculated like this. It basically captures the explained variation in your specification of y divided by the total variation. So if you explain all the variation, then this is just 1, and most likely you don't. So the less you explain, the smaller this number is. So this number is going to be between 0 and 1, and this number is going to be between 0 and 1. And the closer it is to 1, the better you explain your regression, and 1 would be like 100%, and if you explain nothing, it's basically 0, or 0%. Okay, and so your software package or Excel would just calculate the sum of the squared errors. It takes all the errors and sums them and squares them for the regression, and then it divides that by the sum of the squared errors total. Okay, so this gives you a nice explanation of how much variation in your y variable you explain with your regression. Okay, the closer it is to 1, the better it is. Okay, so that's the gist of the R-square. We're gonna stick with something called the adjusted R-square, and that just takes the R-square and does this little transformation. So it's 1 minus the R squared times n minus 1 over n minus k. Okay, and then n is just the number of observations of data points, and k is the number of coefficients. So this makes a nice transformation of the R squared to the adjusted. And the reason you do this is because this number, the R squared, if you add more coefficients, it always goes up a little bit. And so this counts for that. So if you put too many meaningless x variables into your equation, you'll get penalized for this. So basically, this is a better evaluator, I think, because if you put in and leave in x variables that don't make any sense, then this will give you a lower value. So this makes you stay on track with a kind of a better specification. All right. So the final thing we'll evaluate to look at our regression. Actually, let me just mention this, but we're not going to look at this in the homework assignments. But it's important if we're doing just to mention. So the F-stat is another thing to evaluate your regression and how well it does. And so this is a measure of the total variation explained by the regression relative to or divided by the total unexplained. Okay. So this shows you how much you explained in relation to how much was not explained. Okay, and so this is basically going to tell you, these are all ways of looking at how well your data regression fit the actual data and translates to real world interpretations. Like just evaluating the fit of your regression. This shows you how much you explain relative to what could have been explained. Explained divided by not explained. So a different way of looking at how well the regression turns out. Okay, and so what we're going to do is look at a log linear regression line, and then let me briefly mention multiple regression, which is just adding more variables. So let's look at those real quick, because this is kind of what we're going to do in Excel. All right. So like I said, if your price and quantity data kind of match this pattern, and you can fit that little curved line through it, and then you can use a log linear specification like we're going to do. Okay, and so it's basically just taking that log linear demand curve and using it. Here we're just looking at price. So this would be estimating in a linear statistical way. This is ln quantity equals some intercept plus the coefficient or effect of ln price, and then some error term. Okay, so we transform the data into logs, and then look at. So this is the effect of the natural log of price on the natural log of quantity. We know from before that this is going to give us the elasticity. In particular, this will be the own price elasticity of the mean. Okay, so if we make the transformation and we estimate this linear equation, then our interpretation of the coefficient, if it turns out it's a high enough statistic and so on, then that coefficient is the actual elasticity. Okay, and then multiple regression is really just adding more variables. Okay, so we're going to, because we want to look at the elasticities, we want to assume that our variables and quantity have this kind of relationship. So we can estimate the elasticities like this, like a log linear form. Okay, so we're going to transform the data into natural log form and then run a linear regression using least squares like that. So we're basically going to say, depending on the problem, that the natural log of quantity demand of x is a linear function of all the natural logs of all the other variables that affect it. Okay, so this is like the effect of the natural log of price on the natural log of quantity demanded. This is the effect of the natural log of some other related price on the natural log of the quantity demanded of good x. This is the linear effect of the natural log of income on the natural log of the quantity demanded of x, and so on. Okay, and then we know that all of these coefficients are also the respective elasticities. Okay? So when we estimate this beta x is the own price elasticity. This beta y is the cross price elasticity. This beta m is the income elasticity. And then we're going to do another one for advertising. So let's say the beta A, like A is in Alfred. That's the advertising elasticity. Okay, so these have been incorporated into your assignments, so we can look at those. Okay, so all right, so those are the main points I wanted to cover from the lecture slides. Any questions so far before we look at some additional assignments? Okay, looks like we're good so far. Okay, so let's see. All right, so let me just show you on the Blackboard site. There's some. If we like normally in class, I would show you some videos before and during class, and so because of the WebEx lectures, the videos will be optional from now on, or just from. Or let me just show you the ones that relate to today. And so there's one under the videos section of Blackboard. All right, so if you want more on the elasticity of demand, there's one for that. This one's nice for interpreting the coefficients of log models. It explains more of how those coefficients actually interpret the elasticities. So that's a nice one. And then another one just kind of a refresher of regression. Okay, so they're all pretty short, less than 10 minutes. So I'd recommend if you have some extra time or want some more on those topics, then you can just look at those. They're all on YouTube. They're all easy to watch. Okay, so let's first look at on Blackboard under Chapter 3, And so that's what we did last time. And here's for today, chapter 3. You can open up the homework for chapter 3. Okay, so this is the only thing that's due next week, and it's just one problem, but it gives you some nice practice on how to interpret the regression results that we're going to be doing in the data. So this one, homework chapter 3, is just this one. So on discussions for homework for chapter 3, this is due by next Friday. This is due next Friday. And then, like I said, this one, which we're going to talk about after we do this one, is not due until Friday, May 1st. Okay, so here we go. We have a example of just analyzing a regression equation. All right, so at a hypothetical cruise ship company, we gather data on company sales, cruise prices, and average city income, and we're going to estimate the log linear equation, and we're going to transform it into logs so we can get the elasticity. And now we have the natural log of quantity is some intercept and a function of the natural log of price and the natural log of income. Okay, and so I did the regression for this. I think this was a past exam question. All right, so this shows you the output you're going to get from Excel when you do the data analysis. So this is the thing you have to look at to evaluate your regression. Okay, in part A, we just need to write up the equation using the coefficients. And so the coefficients, if you have this say in Excel, are just right here. So these are the betas that you were trying to estimate. All right, so you would do it kind of like this. All right, so there's the general form that we're trying to estimate, and now let's use that to put in our coefficient. And so the natural log of quantity is a function of the intercept, which is right there, 3.088. All right, and plus the coefficient for the natural log of price, which is right here, 0.004. Okay, and then plus the coefficient for income, which is going to be right here, 0.629. Okay, so there's your equation with the coefficients that you estimated, or that were estimated. Okay, so part B is to interpret the adjusted R-square, and that's right here, 0.408. Okay, and like we talked about, this is the percent of the explained variation that's captured in your model. And so it's from 0 to 1, so like 0 being 0% and 1 being 100%. So in percent terms, we captured about 40.8%. Okay, so it's the percent of explained variation. So we explain about 40.8% because it's on a 0 to 1 scale. Okay, so now you want to determine if your coefficients are significant, and that way you can make a meaningful interpretation of those elasticities. And so we're interested in the key statistics that are associated with the natural log of price and the natural log of income. Okay, so we have a t-stat for the natural log of price, which is right there, 0.010. And then we also have a t-stat for the natural log of income, which is right there, 5.903. Okay, and remember the rule of thumb is that these are significant at the 95% confidence level if that t-stat in absolute value is bigger than 2. So all you have to do is say that number, absolute value-wise, bigger than 2, and you see that this one is not, definitely way less than 2. Okay, in this one, 5.93 definitely bigger than 2. So that one holds, that one is statistically significant. Okay, and the final thing, which is the most important, is to interpret the coefficients, which are the elasticities we've been trying to get to the whole time. So we have own price elasticity, one, and we have an income elasticity. Now, the own price wouldn't really hold because it was not significant. There was not enough evidence in the data, but let me just show you how to interpret it anyway. Alright, so the coefficient for the natural log of price is under 0.004. Okay, so it should be the same number you have right there. And the coefficient for the natural log of income is 0.629. Okay, so there's essentially three things that you want to say about each coefficient, and when you do that, so the first thing is you want to define the elasticity, the respective elasticity that you're estimating. So this one is the own price elasticity. Okay, and the second thing is you want to see if there's an elastic or inelastic relationship between this variable and demand, quantity demanded. And that just means if the absolute value is bigger or less than 1. So there's almost no relationship here. And so that's very, even though this doesn't really interpret as a failed t-stat, 0.004 is way less than 1, so this is inelastic. Okay, and then the third thing you want to do is just interpret it we've been interested in how the demand responds to price changes. And you can say that exactly right here with this coefficient. Alright, so this basically shows you the percent response of demand to a 1% change in price. Okay, so it's not much of a conclusion because this variable is not significant, but that's how you would interpret it. So if price increases by 1%, this is the response on demand in percent. So if price increases by 1%, quantity demanded increases by 0.004%. Okay, let's do the same analysis for the income coefficient. Okay, this is the income elasticity. This is looking at how demand responds to income changes percent term-wise. The response of demand is less than that of income, so it's inelastic because that number is less than 1. Alright, so I want to put everything on one page. And then the last thing is you would interpret this coefficient, which is the elasticity for income. So this is the response of demand when income changes by 1%. Okay, so the first one doesn't really tell you much because the own price elasticity didn't really hold. So that, I just want to show you the interpretation that this result, if you were doing like a research paper or talking about it, there'd be no reason to mention that because it doesn't even say much. But this one shows you that demand responds to income. So basically, every time people get an additional 1% more of income, they spend another 60% of that on this product, which is pretty valuable. Okay, so I guess we basically did the homework, but I wanted you guys to see how to do this for the bigger project. Any questions on how we did here? And so this is how you can interpret all the results. But now I have to show you how to do the actual analysis in Excel. But first, let's make sure that we're good on this. Okay, so that assignment, which you've pretty much already done, is due next Friday. Okay, right there, homework chapter 3. Now the thing I'm going to show you now, the elasticity homework, the longer assignment, is you got to do some data analysis. And again, this one is not due until May 1st. Okay, so now let's open up the elasticity homework document, because this is the one that we'll be due in a few weeks or so. Okay, so here we have, there's some data sets provided from the textbook, and I'll show you how to get those. And then basically you're gonna take those data sets and run some regressions in Excel, if you can, and then interpret the results. Okay? So also, if you go back to the chapter 3 section, like this on Blackboard, you can open up this thing that says Bay 9E document. That's the link to the data. Okay, and so you'll see that the questions, the homework assignment we just did, the questions are pretty much the same, but you have to do the data analysis in Excel. So number 12 is we have some data for, let me see, number 12 is, and if you want to see what the questions are referring to, that's at the back of chapter 3. Okay, so you don't have to do the questions. I just wanted to get the data sets and do our own analysis, but if you want to see what you're analyzing, this is problems and applications number 12. Okay, so you're looking at some alkaline batteries and some data on price and income on that. And so for this first one, if you go down to this other document, the Bay 9E, it has the links for the data that are associated with the 9th version. And so the link for problem 12 is right here. Okay, so if you open that up, you should get this data for question 12. So you have some natural log of quantity, some corresponding natural logs of price, and some corresponding natural logs of income. Okay, so it didn't work? Oh, okay, so you click on a link and it doesn't do anything? Well, I can just post them on the Blackboard site. Okay, so if it doesn't work, don't worry. I'll put the data sets on Blackboard right now. So we need the ones for 12, 18, 19, and 20. Okay, it works. Okay, so well, it looks like it's working, but I'll put them on there just in case because, uh, okay, let me finish downloading them and I'll put them on Blackboard just in case, and I'm almost done. Okay, so I'm gonna post them on the chapter 3. And so you can either use the ones I post, or if you're able to open the link, you can use those. But either way, you want to resave those as a new Excel file, which I did. So you can either use mine or just, if you got it to work, just save as, like a new thing. I don't know what I did with the other one. Okay, hold on a second. Okay, so you should be able to go to Blackboard now, and under the chapter 3, I just posted the 4 files you need, and so you can just use these if you want, or if you got them to download, you can use that too. But they should all be here, and here's the one for for question 12, 18, 19, and 20. Okay, so does everybody see where to get the data? Okay, let's go back to the New Access to homework. All right, and so the data set for question 12 is this one here, Q12. Okay, and you're going to estimate a log linear relationship in Excel between the natural log of income, the natural log of quantity, and the natural log of price, and the natural log of income. And then you're going to answer the questions, and I'll show you how to do the analysis. Okay, and then for question 18, there's that data. Okay, in this one, there's only price and quantity, so you're going to estimate the natural log of quantity on the natural log of price. And then all the questions are the same that we just did in the homework. The only difference in part A is to include the screen cap, which after you do the regression, and everything else is you write out the coefficients. Okay, so once I show you to do the analysis, you're going to put the screen cap use the coefficients to write the equation, interpret the R squared, adjust R squared, determine using the t-stats if they're significant. Yeah, just like you can either copy and paste the Excel, or just, like take a snip, or like a screen cap, right, like a picture. So that's a screen cap. And then, number 19 is you're going to estimate the natural log of quantity, the natural log of price, and the natural log of income. And this one, if you open up the Excel file for question 19, this one, you can see that there's 7 tabs. You only have to do one. And I made a list. I'm going to do one as an example right now. And then the other 6, I basically assigned because there's 30 students. So 5 students per state. So you just have to do the one you're assigned to. And so if you look, so you can open this up if you want. Under Chapter 3 of the Q19 state list. Alright, so I basically just, based on alphabetical order, I put you guys I assigned one state, like the first 5 people in the alphabet, last name wise, get Indiana. And so just look at the little chart, and that's your state. So 5 of you are Indiana, the other 5 are Michigan, so only do the one state that you're assigned to, and you don't have to do the other one. So just pick the tab with your state, and do that one. Okay, so like, this is Wisconsin, this is Ohio, this is Mississippi, Minnesota, Michigan, Indiana, and then I'll do Illinois for an example, and then the other ones, just do the one state that you're assigned to. Okay, and then question 20, you have the data right there, Q20. And this one, you're going to estimate the natural log of quantity and the natural log of price. And then you also have the natural log of advertising for this one. Okay, so they're all the same process, and the interpretations are pretty much the same. But let me show you how to do I'll do one of the question number 19 for an example, and then we'll see if we could. Everybody understand what we have to do after we do the Excel stuff? Okay, so I'll do the analysis for number 19 as an example, and I'll put that on. I'll post it on the. Did I already put it on there? Okay, so maybe not. But I think I already did it, but I'll do it again, and then I'll post it for an example you guys can look at, and then you can do the same. What does the column data represent? They're just different observations. So like, basically when when demand was $5.75, this was the price, and this was the average income. So just different segments of observation. So there's no time involved. You're just trying to estimate how these things affect quantities demanded based on the data set. Okay, so if you're able to do Excel right now, or you can just watch, but let me show you how to do it in Excel. And then I'm not sure if everyone's going to be able to do it, but hopefully you can. If not, I can help you with the analysis. Okay, so here is I'm going to do the Illinois one for an example. And to estimate the equation or do the linear regression in Excel, you want to use the data analysis feature. And if you click on the data tab, you might see the data analysis option. If you don't see it there, you might just have to check it or to load it. And so let me show you how to do that real quick. Okay, so let me show you how to enable the data analysis feature if it's not enabled. As you click on File, and it might be a little bit different if you're using a Mac version, but I'm sure I can help you do that too. But for Windows, File, then Options. And you should see the Add-ins option. And then down there where it says Manage Excel Add-ins, click on the Go button. Okay, and if you have this with your Excel package, which I think most of you should if you have the full version, you should see something called the Analysis Toolpack, and that's what you want to click on, and that's the data analysis. So if you've got here and you see the Analysis Toolpack, just check it, put a little check mark, and hit the OK button. Okay, so were you guys able to get the data analysis feature? Okay, so does anyone using a Mac that doesn't have it or needs to do it with a Mac? Okay. Okay, so it looks like, at least so far, that there's no issues with getting the data analysis, but if there are, you can let me know, and I'll try to help you with it. So let me show you how to do it with data analysis for this problem. Okay. Okay, so I think all the other data sets already have the natural log calculation, or they already have the natural log data. This one for the states, you have to just transform it into natural logs. It's really easy. And let me show you how to do it for my example. And so we have the quantity, price, and income. We just want those numbers in natural log form. Okay, so I'm going to make 3 more columns for the natural log of each thing. Okay, so again, we have quantity, price, and income. We want those in natural log so we can estimate the natural log equation and get the elasticity. Okay, so all you have to do is, I'll start here in E2. You just type in equals. Okay, you should have a natural log function. It's really simple, just ln, and then just put the first data point in, which is A2. Okay, so the natural log of A2, there's that. All right, and you can just copy the formula down, and it'll do the same natural log calculation for all the quantities. Actually, you can you should see that bottom right corner. You can drag that over here and then over here. Okay, so this is now the natural log of the first price, V2. And this is the natural log of the first income, C2. Okay, so if you select all 3 of those, all you have to do is drag down the formulas. It'll do the calculations for you for all the natural logs. So just do this. And that should do all the natural logs. See, it goes down, so like A2, A3, and it goes all the way down to A51 for the last quantity. And this one should get all the prices. And this one should natural log all the income. Okay, so all you did is put everything in natural log form, because you got to have that to do the elasticity regression. Okay? Alright, so now I'm going to show you how to estimate the least squared regression using data analysis with Excel. Okay, so if you click on the data tab and you were able to get the data analysis, so data tab, and then click on data analysis. Okay, so it should give you this data analysis tools box options. You want to scroll down and just choose regression. That's the only one we're going to use for now. So select regression. Hit OK. Okay, and then you want to select your Y range first, which is just it's always going to be the natural log of quantity, because that's you're trying to see how everything affects that. So hit this button. Okay, and you want to choose the entire natural log of quantity column, the whole E column. So I selected E1 to E51. All right, the whole column, including the title. Hit that. Okay, you want to select your X range, which is both the natural log of price and the natural log of income. Hit this button. And then you want to choose the entire F and G range, including the titles and all the data. So basically, I selected F1 to G51 to get both of those columns together. And just hit that. Okay, and then before you hit OK, make sure you hit the labels box. And that will give you the name of the variable when you get the printout in your screen cap. Okay, so all you have to do now is hit OK. Are you guys able to follow along this far? Okay, so we got our specification. Let's hit the OK button, and this should hopefully give us our regression output. Okay, so here it is. This is the same thing we looked at in that screen cap. I like to, you're welcome to do whatever you want, but I like to take away a few decimals so it's easier for me to see the numbers. And so I kind of prefer things and gives you like 2 decimals. And that way it's easier just to round things off. Okay, so if you select everything and just change the format to 2 decimals. Alright, so again, this is just a personal preference. I think it's easier to see the numbers when there's less decimals. So under the Home tab, if you click on Format, the drop-down thing. Yep. Format cells. Okay, and just choose the numbers option. And I like to have 2 decimals with the comma separator. And then you can just hit the OK button. Alright, so now I think it's a lot easier to see the coefficients with like 2 decimals is fine. Okay, and so this is everything you need to interpret the regression. And so if you want, I kind of like to highlight the things we need, and that way when I take the screen cap, I can just see it really easily. So we need the adjusted R-squared number. We need all the coefficients. Okay, we need the t-stats to see if it's significant, but you only need the t-stat for the non-intercept variable, so for the natural log variable. You don't need to worry about the t-stat for, it doesn't matter if the intercept is significant or not. It just has to be in there to complete the specification. So you can ignore this t-stat, but these two are important. Okay, so I like to go ahead and just do that and just highlight the things we need, and that way when I'm talking about it in the homework, I can just see what I need to talk about. So those are the things that you need to focus on when you do your homework. Was everybody able to get the summary output from Excel? Okay, so then let me just show you how to interpret this one, and then you kind of do the same thing for all the other questions. So depending if you're using a Windows or a different version of operating system, I just usually use the snipping tool in Windows 10. Okay, so you can see, I just took a screen cap, and I'm just gonna put that into the Word document, like this is the picture that shows the results. Okay, and then, so it's probably going to come out when you put the screen cap and answer the question. You probably need like a 1 page per question in Word. And so it'll probably be like 4 pages if you include the description of the questions and the A, B, C, D, E. Okay, so I'll put my screen cap here, and then I'll do number 19 as an example, and then you guys should be able to do the analysis for your state. Right? So again, just do the one state that you're assigned to based on your last name. Okay, so there it is. I just put in the screen cap of my output. So that's all you need, and then you got to talk about it and answer the question. So again, this is for Illinois as an example. Okay, so for each of the 4 homework questions, the first part A is just to put in the screen cap of your regression results, the summary output. So there's that. That's done. And then parts B through E is to interpret it like we did in that homework question. So you can write the equation. Remember, the equations are different, so just specify the equation based on the specific question. So if you only have, I think all of them have price, but some have only price, some have income, some have advertising. So only put the variables in that you're actually looking at. Okay, so this one we're looking at the natural log of price and the natural log of income, just like I think the homework question. Okay, so that's the general form, and we have to put in the coefficients. So part B is to write the equation using the estimated coefficients from Excel. Okay, so the coefficient for the intercept is right there, 0.99, and it'll be different for your state, unless you're doing the same state as one of your classmates. Okay, so yeah, maybe if you see you're assigned to just to double check, if you see you're assigned to the same state as somebody else, you can just double check and see if you got the same results just to confirm if you want to. Okay, and then the coefficient for the natural log of price is 0.35. And the coefficient for the natural log of income is 1.14. Okay, there's your equation. All right, now let's interpret the adjusted R square. All right, so you can see that this is a very bad fit. Didn't explain much, only about 5%, and so my adjusted R squared is 0.05. Okay, so I only explained about 5% of the LNQ this time. Not very good. All right, let's see if the coefficients are significant. Okay, based on the t-stat. Okay, so the t-stat for natural log of price is 0.38. And the t-stat for the natural log of income is 2.17. Okay, so let's do the rule of thumb test. Check if it's bigger than 2 in absolute value. If it is, then it is significant. If it's not, it is not. Okay, so the price variable is significant. The price variable is not significant. The income variable is significant. Okay, and then for this assignment, you only need to interpret the ones that you have a clear statistical relationship. So for this one, So part E says interpret the coefficients for your explanatory variables, and it says significant variables only. So this is like what you would report. Okay, so for the price, L price, there's a really small t-stat, probably a really bad fit, and so we're going to assume that the data doesn't give us a relationship to talk about. So if it's not significant, don't bother interpreting it in the part E part. Just interpret the ones that are significant. So it's going to be, it might be 2 variables, it might be 1, it might be 0, depending on what you get in part D. So we only need to talk about here, or I need to talk about only the natural log of income because the other one was not significant. The coefficients of natural log of income is 1.14. Okay, and then the coefficient for price is 0.35, but because it's not significant, the coefficient interpretation doesn't really hold, so don't even worry about it. Okay, but we have to interpret this one like we would before. This is, number 1 is what type of elasticity is it? That's the income elasticity. Number 2 is this inelastic or elastic? And this time, the number is bigger than 1 in absolute value, so it's elastic, meaning demand is very responsive to price. I'm sorry, very responsive to income. Okay, now let's interpret this just like it would be in terms of the responsiveness of demand to income. Okay, so this shows the responsiveness of demand percent-wise to income changes. And so this is what happens if income goes up by 1%. That coefficient is the response in demand. You can see that demand is more responsive than income, so the consumers really buy more of this good when they get more income. This example. Okay, and so again, maybe just look at the examples at the end of chapter 3, just so you know what you're talking about, or just so you know what you're estimating. And so this is first a hypothetical microbrew company that sells breweries, like cases of breweries in the States. And so what my data showed is that when these consumers get more income, they buy a bigger increase in beer consumption than they would in their income. So like a 1% growth in their income means they buy over 1% more beer. Alright, so you can interpret this just like you would. This is if income Okay, so if income goes up by 1%, what's the responsiveness of demand? You can see it goes up by 1.14%. So it's more responsive than income. All right, so if income increases by 1%, quantity demanded increases by 1.14%. And I guess we haven't had any negative coefficients yet, but if you do, like if any of these coefficients were negative, that means demand responds in a negative way. So like if you have like This is just an example, but if you had a natural log of price coefficient that was negative and significant, you would interpret it based on the negative relationship. So let's say that it was a negative, let's say the coefficient for the natural log of price was -2. Now, if it was significant and if you had to interpret it, you would do it like this. Okay, and so we know it's the own price losses, so we know that it's absolute value that determines the degree of elasticity. So -2 in absolute value is 2, so that's elastic, because it's more responsive than price. Okay, and you would interpret it as the same, but just note that we have a negative relationship, like we probably should have, between price and quality. So this would mean if price goes up by 1%, that's the response of demand. Alright, so if price increases by 1% based on that coefficient, quantity demand decreases by 2%. Alright, so this last part was just an example if you had a negative coefficient. Okay, so any questions on what we're doing here and how to do the analysis and interpretation or anything else? So LNP is not -2. That was just an example if you had a negative coefficient. So because we had never done a negative coefficient interpretation, and so I just wanted to show you an example if the coefficient was negative. Okay, so this is an example if the coefficient for LNP was -2. So it has nothing to do with this regression we did. I just wanted to do one for a negative. So some of you should get some negatives for your prices because that's the law of demand. Okay, so just to summarize, the homework chapter 3, that one question that we just did together, that's due next Friday, right there in the discussion forum for chapter 3. Okay, and then the elasticity homework, the 4 questions of the data analysis where you do Excel and then you do the interpretation. So that is due here, again, May 1st. So that goes right there. Whenever you're done with it, just do it by May 1st. And you have some time, so if you have any Excel problems or anything else, you can let me know. And then next week, we are going to do chapter 4 in your textbook. Homework chapter 3 is due next week, which is pretty much already done. And then, your elasticity homework is not due for a few weeks. All right. So any questions on the project, on the elasticity homework, or anything else for today? Or any Excel questions? Okay. All right. You're welcome. And okay, so there were 30 participants again today. So there was one person who emailed, or one student who emailed saying that he or she couldn't make it. And so I know everybody else was here based on the 30 participants. So you guys are all good for attendance. That's about it for tonight. If you have any, I'll stay on until everyone logs off just in case there's any questions. But if you're good with homework and the elasticity project thing, you're welcome to log off. And I'll see you in a week next Friday at 6.